Let's illustrate how we add two integer together to obtain the summation of the two numbers using pointers. As we can see here with three integers, a, b, right, and r. And we're also going to be creating pointers, each pointing to each respective target. And then we're going to make use of these pointers to effectuate the summation of the two numbers. So we have three declarations here for the integers and three declarations for the pointers. In addition to the declarations, we are also initializing each pointers with the address of their respective integers here. And of course, none of these integers have any value associated with them. So we're going to ask the user to enter values for a and b, and then we're going to make use of pointer to arrive at the value of r, which is a summation of a plus b. Right, so the user is going to enter a number, and that number is a digit that's going to be stored inside this PA, and this value inside of this. And the reason why this could be the case is because PA is equal to %a, right? And PB is equal to %b. So alternatively, you can replace PA with %a, PB with %b. From the earlier video where we talked about scanf, the parameter that we need to have the value stored in must be of a pointer type. This is the reason why you can use %b or %a, because PA and PB are both pointers. You would apply unary expression, the start, which is the reference operator. The reference operator gets you back the value of a, and so is this giving you back the value of b. So a plus b equals whatever that number is, and number is r, but in this case we're using the reference PR to represent the value of r. So alternatively, you can also say r equals PA plus the reference PB. This is the same, this will have the same effect as this, So this is the example, and then you print this out and you can see the additions, 15 plus 51, assuming the user enters 15 and 51 respectively for the first number and second number. So this illustrates the use of pointers and pointer operations to get you the summation of two numbers. We have three integers, and there's only, instead of having three pointers, we just have one, and this pointer is an integer pointer. That can point to A, and then B, and then C, respectively, one at a time. So this illustrates the use of just one pointer and its flexibility. So let's look at the code. So here we see the three integer, and then one pointer, and these are integer pointers. So we ask the user to enter values, for A, B, and C, respectively, in one shot. So these are %a, %b, and %c. And these stands for the address of A, B, C, S is required, as part of the scanf parameters. Now that we have value for A, B, and C, we then assign the address of A, whatever this is, the reference P to point out the value of it. And so the very first one, A is 10, B is 20, C is 30, and after that, note that line 21 illustrates that the pointer is reassignable. So you can assign the addresses. These are ultimately just integers, Addresses are integers. So now P equals the address of B, and then you print out what that value is, which is 20. And then line 23 illustrates, again, we're using a single pointer, to point to now another address, So you can simply just use one variable to point to various different locations. This is a flexibility involving pointers. Because the pointer itself is not constant, it is therefore assignable, Just like creating any variables, like integer, k, and you can assign a value of 5, and later you say k equals 100 this time, At some point you can say k equals -1. So that's essentially what happens, with pointers. And this gives you the three values using one pointer, as this example illustrates. All right, so this example illustrates the opposite fact. Now we're just going to have one variable declare on a stack. And then we're going to ask the user to enter this value. But now we have 3 pointers. They all pointing to the same, central location, which is A here. So let's illustrate what this is looking at in code. All right, so the declaration here shows there's a 1 integer and 3 pointers pointing to the same location, ampersand A, ampersand A, ampersand A, right? The address of A. We ask the user to enter what this A is, right? So using scanf, right? The second parameters here is that, right? D, which is that integer, which is the address of A. And now remember P, Q, R, right? They all point to, right? A here. So if we dereference P, we get back A, right? Which is 15, assuming A is 15. If we dereference Q, we get back 15, which is what A is. If we dereference R, we get back the same value as where R is pointing to, which is A here. So this illustrates the use of many pointers pointing to a variable.